Hello everyone. I hope you're all keeping safe. My name is Palak and I work as a senior safety engineer at Lyft Level 5. And I also act as a safety advisor for the University of Toronto self-driving car team. I'm really excited to speak at the conference today and share some thoughts around autonomous vehicle safety challenges. And with that, let's get on to the first slide. Now, before we get into talking about some key technical and regulatory challenges for AVs, I'd like to take a moment to talk about the level of transportation that has increased over the past years, from early cars with minimal electronics and with driver performing all the functions to L1 autonomy with driving assist features like ACC, adaptive cruise control, or lane keep assist, to L4 autonomy where the driver is not required to intervene at all. However, for L4 autonomy, there are some restrictions as full autonomy mode can only be activated in certain geofenced areas. All the way to L5 autonomy, where the vehicle is capable of performing all functions under all conditions through ability to sense its surroundings. Now, as the level of transportation has increased over the past years, the level of safety has also increased significantly, all the way going from having minimal electronics to support the driver to having multiple levels or layers of autonomy software stack with vehicle, enabling all the functions or vehicle performing all the functions under all conditions through ability to sense its surroundings. Now, before I get into, to talk about some of the key technical and regulatory challenges when it comes to deploying AVs on public roads and at scale, I'd like to give a bird's eye view of different pillars of autonomous vehicles so that, when we get into challenges, it'll basically give you a good understanding of the scope of those challenges. So starting with sensors, now starting with at the very top of the vehicle, we have sensors. Sensors, different sensors like camera, radar, and LiDAR, they collect or gather information 360 degrees around the vehicle. That information is fed into autonomy. Now, sophisticated algorithms, they gather or they process the sensor data, enabling the autonomous vehicles to understand its environment. Algorithms like neural networks, they help process information, learn, and classify the objects in the surrounding environment. That information is fed into vehicle controls, that is engine, brakes, and steering system to operate the vehicle or to control the vehicle. Last but not least, we have electrical signals that moves through the vehicle's controls that connect the computer to the engine, brakes, and steering system to operate the vehicle. Now, these different pillars of autonomous vehicles, they comprise of key technical terms that you might have used or even heard before. And some of them are just highlighted here, like perception, prediction, planning, and localization that fall under autonomy software stack that help process the information. They process the sensor data, and then based on where the predicted or the motion of the surrounding objects is going to be, it basically plans a route for the vehicle, and that information is fed to vehicles controls. And along with that, we have some other terms like power management, weatherproofing, and integrated design. Now, each pillar in here, it has its own complexity. And when you combine these different pillars of autonomous vehicles, the level of safety just increases altogether. And with that, let's talk about some of the key technical challenges for AVs. Starting with managing complexity at scale. Now, traditional automotive companies, for the past so many years, they have been manufacturing vehicles with compliance to functional safety standard, that is ISO 26262. Now, with autonomy stack and with added complexity, the level of safety increases significantly, all the way going from or ranging from detecting sensor failures, like detecting camera, radar, or LiDAR sensor failure, to effectively detect, localize, and classify objects in the surrounding environment is one of the challenges when it comes to minimizing perception errors. Also, to make sure that the vehicle's controls, like brakes, steering, and engine, they operate or they basically send out correct and in a timely fashion actuator commands is also another area where safety plays an important role. Now, when you talk about functional safety is only focused on detecting system failures and reacting to those failures, right? So what happens if there is a sensor failure? What happens, if the system or the autonomy software stack does not, detect the obstacle correctly? What happens if there is a delay in the actuator command to the vehicle? So all of these are categorized under system failures. Now, consider a scenario where there is no system failure, but because of some technological limitations like sensor performance limitation or inability to address or inability to comprehend a situation and operate safely, or inadequate or having inadequate training data set to operate under different or in different for different conditions or under different conditions. Now, because of these corner cases or use cases which is outside of system failure, that the output of the function is unintended, or in other words, the vehicle is not doing what it's supposed to do. And this is where the second challenge or even the second standard comes in the picture, which is called SOTIF. Now, SOTIF stands for Safety of the Intended Functionality. SOTIF standard focuses on providing design, verification, and validation measures. And applying these measures, it just helps us achieve safety without failures. So if there is no system failure, then how do we make sure that the system or the functionality of the vehicle is still intended, that it's doing what it's supposed to do? Now, someone might ask this question like, how do we achieve safety? In other words, how do we measure safety? How do we know that the system is safe enough? Or in other words, how do you define a metric for safety, for the safety of the system? And this is where the third challenge comes in the picture: verification and validation. Now, with again going back to the previous thing, with autonomy stack and with added complexity, the level of safety increases. And on the other hand, in parallel, the level of testing that's needed, it also increases significantly. For autonomy stack, you have to make sure that you have captured all the use cases and corner cases that does not just rely on system failures, but also on these SOTIF specific use cases. For example, if there is a bright sunlight on camera lens, right? It's still doing what it's supposed to do. There is no system failure or malfunctioning behavior, but it might not work the way it's supposed to, which could lead to some unintended functionality. So making sure that define a metric for that, it's a big challenge. Last but not least, we have cybersecurity. Now, due to the extreme connectivity within autonomous vehicle components with other vehicles, that is V2X, or in other words, vehicle-to-vehicle communication, and their operating environment, one of the challenges is to protect fleet and customers from cybersecurity attacks. Connectivity additions include like IT backend system or new interfaces between the connected functions or between the control functions of the connected vehicles and other external information sources. This rich cyber attack or this rich attack surface, it basically creates considerable interest for malicious actors with lots of with again going back to the complexity and going back to integrated design of the system. Going to some of the regulatory challenges, along with these key technical challenges where it's still, a lot of things are unknown and we are still working on defining standards for those. There are also some regulatory challenges when it comes to deploying AVs on public roads and at scale. Starting with proving customer safety, and this is something that a lot of people that I've worked with, or even I talk to, they basically think about this, and even I do sometimes. And I started to work on safety, that is proving customer safety. Right now, before any reasonable on-road rollout, customer or consumer safety has to be paramount with rigorous testing for all autonomous vehicle components. Now, if you think of it in terms of statistics, in a recent survey, 2/5 respondents, they expressed comfort with low-speed AVs. However, that dropped when asked about a high-speed environment. In other words, or another way to think of it is, the expectation from AVs is to reduce the number of crashes, or especially fatal crashes, as compared to human-driven cars, right? Because they are run by machines that have less scope of errors. And if AVs are not able to establish this clearly, it'll be a significant setback for the adoption and rollout of AVs. The second one that you think about is liability, right? Now, current liability laws, they mandate manufacturers to be liable for safety incidents. Now, because of the steady shift in vehicles' responsibility from the driver to an autonomous car, may see a similar change in liability from the driver to the manufacturer. So developing unsafe products, it implies that manufacturers will be legally responsible for accidents involving their products. Last but not least, we have building AV conducive infrastructure, which is where government will have to closely monitor the development and evolution of AVs, and they'll have to determine the impact this technology will have on road infrastructure, our cities and communities when it comes to deploying AVs on public roads and at scale. Short and sweet from my end, and I'm just next to Q&A as I'm open to answer any questions that you might have, or I'm happy to take any comments, suggestions from any of you, and obviously happy to connect to you on LinkedIn.
Thank you so much, Palak. And now we're seeing a wild kaleidoscope of your shared screen. There you go.
Yeah. Sorry.
Always wild. Yeah, I mean, so far from your conversation, there's a few things I think that stand out. I know sometimes when you're kind of moving quickly to get all the information in for us, there's sometimes things that you think to yourself, I would have spent more time there, but I wanted to make sure, everything was said correctly within my time. Seeing as we do have a little bit more time, is there one piece you'd love to kind of like give us a little bit more on while we have you?
Sure. I think when it comes to, implementing safety strategies or key different principles of safety, right? When you talk about building safety principles for AVs, we basically start off with functional safety as a basis. As I mentioned before, traditional automotive companies, they have been manufacturing vehicles with compliance to this ISO 26262 or functional safety standard for like so many years. When we talk about implementing safety principles for AVs, we basically start from scratch. In other words, we start from the basic. So we have to apply functional safety, which helps us define some key safety management related principles, right? Beyond is where a lot of unknowns and a lot of these corner cases and use cases that comes in the picture, and which is where I think a lot of focus is going to go in, and a lot of standards or a lot of organizations, either IEEE or SIE, they have been working on right now. Even AVSC, which is a safety consortium, they have been trying to get to a point where how do you achieve safety? How do you define a metric to safety, for AVs? Because it's really difficult to, when someone asks me the question like, how do you know whether that's safe enough? You can do X number of hours of testing. You can do different levels of testing. You can test it, at different levels. You can test it on the vehicle. You can go to a field to test the vehicle, or you can do it on the bench, right? Which is like a specific test setup for the safety. But how do you know it's safe enough? So I think defining a metric, or how do you measure safety is a big question or a challenge, for AVs.
Do you feel like, Palak, like the speed of these safety testing and mechanisms is going at the pace that you expect it should go?
I guess yes and no. I mean, all the tech companies they're working on right now, they are doing, amazing job, right? But I guess it comes back to the question of what are they like? Whatever they are doing, is that good enough? Again, going back to the same thing, right? The speed at which they are going, I don't think that commercializing AVs is going to happen right away, or even for the next couple of years. It's going to take a while for us to commercialize AVs, right? And as we were talking about L4 autonomy, right now we are only able to engage in autonomy for most of the tech companies that you talk about. We're only able to engage in autonomy and test it out just in certain areas or geofenced areas, right? But commercializing that over like everything, it's going to be a big challenge. And I don't think we have the regulatory standards in place yet to even get to that. So even if we go to that L4 autonomy, going from L4 to L5 is going to be a big jump. And yeah.
Do you think regulatory standards will happen in some countries before others, like where legalization will happen earlier in certain areas of the world? And if so, is the US one of them? Where's the kind of fastest moving process on the regulation side?
That's more on the regulatory side. I'm not so sure I know a lot more about regulatory because it goes back to compliance and legal side of things. But I know a lot of folks are actually working on it, and Europe being one of those. I'm not sure if they are, as compared to US, whether they are, ahead or they are behind.
Mhm.
But yeah,
Yeah, well, I
a lot
asked
of
from
these,
that country
yeah.
just because that's where the office that you're at is located. But okay, so
Yeah.
interesting. Falak, what do you see the future as in this realm?
Just sit back and relax, take a nap, read a book, and try and not think about safety. And this is where the regulatory challenge, it's very important because proving customer safety and, you know, we'll have to make sure that there are different ways to do that, but I guess we'll have to make sure that we prove customer or consumer safety deploy or start to deploy AVs on public roads and even at scale. Because if we can do that, then I think the only thing that I'm going to do is just sit back, relax, take a nap, or enjoy a drink, and just let the car do its job.
Yeah, yeah, absolutely. And I'm sure people are commenting and thinking that same thing, right? That'd be the best. We could get to
Yeah,
work on my commute and not need to do anything. Well, I have a question in the chat too for you. How do you think AI is going to impact on autonomous vehicles specifically?
well, I guess a lot of it, when you talk about autonomy software stack, right? AI or machine learning, I think a lot of it is just interlinked together. So it's not interdependent. They're all so dependent. And when you think about all of these different levels of autonomy software stack, like prediction, perception, localization, or planning, this is actually the bigger piece of us to ensure safety, right?
Mhm.
Vehicle control is something that we have been doing it before as well, and for us to make sure that we are able to send out correct actuator commands to the vehicle, we still have some idea of how to do that, but making sure that we're getting correct or adequate training data set from neural networks, or we don't have, or minimizing perception errors, that we are able to detect obstacles correctly and in a timely fashion, right? How do you make sure of that? I think this is where it's actually a big challenge. And this is where I think AI and machine learning is going to come in the picture, of course.